Welcome to another lesson. This lesson we are going to look at past exams that have been tested on matrices, and specifically we are dealing with the application of matrices. So here we are going to look at an exam that was tested in the year April 2023, and this was question number 3A. The question reads, using the information given below, determine the level of output necessary from each sector to support a final demand of 500 for sector X1, 1,600 for sector X2, and 2,000 for sector X3. When you get this kind of a question, the first thing to do here is to come up with your matrices. Once you get your matrices right, the next step is getting the technological matrices. It's very simple. You have already been given the format or how your matrices should look like. This is X1, X2, X3. We have also X1 on this side. We have X2, X3. This is 40, 40, 40, 40, 80, 80, 400, 1,200, 280. Now, this has to be added with your final demand. Final demand. Let's get a matrix for final demand. Gives us what? This is 680, 1,400, 2,120. We should get the total. This one we need to get the total output. Total output here. Total output, we need to add 40 plus 40 plus 40 plus up to the last one. So here we have 40 plus 40 plus 40 plus 680. This gives me what? If you add this one, the total here gives me, total output here is 800. The total here is 800. The next one is 40 plus 80 plus 80 plus 1,400. This gives me 1,600. 1,600. And finally, 400 plus 1,200 plus 280 plus 2,120. This gives me 4,000. Now, once you are able to get your matrices right, the next thing to do is to come with technological coefficient matrix. Get your technological coefficient matrix. So I'm having X1, X2, X3, and also X1 on this side, X2, X3. Here, from the matrices above, I will take the first column you divide by 400. This will be 40. This is 40 divided by 800. We also have 40 divided by 800, and here is 400 divided by 800. x2, we shall have, you divide this one by the total 1,600. Divide by 1,600. 80 divided by 1,600. And this is 1,200 divided by 1,600. Here I will have 40 divided by 4,000. Then here I get 80 divided by 4,000. And here is 280 divided by 4,000. When you do it right, you get that 40 divided by 80, this is 0.05. The same here, 0.05. And then here it is 0.5. 40 divided by 1,600, this is 0.01. This is 0.25. Then here you get 0.05. 1,200 divided by 1,600, you get 0.75. On this end, this is 40 divided by 4,000, you get 0.1. This is, you take your calculator, you find that this is 0.01. 0.01. Then 80 divided by 4,000, this gives you 0.02. And this one give you 0.07. Good. Those are the technological coefficient matrices. From the input-output model, we know that for you to get the total output is 1 minus A inverse, not in the, this is I, this identity matrix, inverse multiplied by Y, or multiplied by demand. So I need to find I minus A. So here, this is a 3 by 3 matrix. So identity matrix here becomes 1, 0, 0, 0, 1, 0, 0, 0, 1. I subtract my coefficient matrix 0.05, 0.05, 0.05, 0.025, 0.05, 0.75, and this is 0.01, 0.02, 0.07. Next is 1 minus 0.05. This give me, we are working on one identity matrix minus A. This is 1 minus 0.05. The matrix here becomes 0.95. The rest are negative because this is 0. So this is negative 0.025. And this is negative 0.01. The first one gives me negative 0.05. Then we have 0.95 because it's 1 minus 0.05. And this is negative 0.02. This is negative 0.5, negative 0.75. And this is 1 minus 0.07, give me 0.93. Now, from here we need to find the inverse of a 3 by 3 matrix. How do you get the inverse? We need to find the inverse. Inverse of 3 by 3 matrix. The first step, we begin by getting the minus matrix. Minus matrix. The minus matrix, where we have 0.95, I cancel the rows and columns touching 0.15 so that I can find the determinant of 0.95. Then you have negative 0.02, then we have negative 0.75, then 0.93. I'll come to the second row, first column. I cancel the rows and columns touching negative 0.05. I will be left with negative 0.025. Yeah, I'm cancelling those ones, and then I have negative 0.01. Then I have negative 0.75. Then 0.93. You find the determinant there. Similarly, third row, first column, the minus there is negative 0.025, negative 0.01, negative 0.95, negative 0.02. I'm done with that column. You do the same on the others. So I go to the second row, first column, I look for the minus matrix. So here I'm going to have cancel the rows and columns touching negative 0.025. So that gives me negative 0.05, negative 0.02, negative 0.5, negative 0.93. Second row, second column, cancel the values touching that touching 0. This is 0.95. This one, you cancel those rows and columns touching 0.95. So what do you get? This is 0.95, 0.01, negative 0.5, and 0.93. Third row, second column, we get 0.95, negative 0.01, negative 0. This is negative 0.05 and negative 0.02. Lastly, we go to that first column, that first row, that column. We get here we have negative 0.05, 0.95, then we have negative 0.5, negative 0.75. Second row, that column, we get the minus there. This is 0.95, negative 0.025, then negative 0.5, negative 0.75. Finally, we have that row, that column, 0.95, negative 0.025. We have negative 0.05 and 0.95. So we have obtained the minor matrix. The next step after here is for you to find the determinant. Find the determinant of those minor matrix. Find the determinant. How do you find the determinant? You get the product of the main diagonal, subtract the product of the other diagonal. The first one will be 0.95 times 0.93 minus 0.75 times negative 0.02. So here you get, this is 0.8685. Here you get negative 0.03075. Here we have 0.01. We move the same to the first row, second column. We get the determinant. This gives us negative 0.0565. Get the determinant here. 0.95 times 0.93. Subtract negative 0.5 times negative 0.01. Here gives you 0.8785. And this one is negative 0.0195. Finally, we move to the third column, where you get this is 0.05 times 0.75. Product of the mean diagonal, subtract the product of the other diagonal, which gives you 0.5125. This is 0.5125. This is 0.5125. 5125. Let me make it clear. This is 0.5125. 5125. Then the next one, this should give you negative 0.725. This is negative 0.7. This is negative 0.725. Let me just wrap this. I said this one here should be 0.05 times 0.75. Subtract 0.5 times 0.95. This one should be 0.5125. Then this one is negative 0.725. And then the last one is 0.9. I think my pen here, let me just reduce this space. Let me reduce this space here so that it becomes clear on what I'm doing. Okay. I want to reduce this space here and write this was 0.0565. This is negative. This is 0.8785, and this was negative 0.1. This is negative 0.0195. Here I'm having 0.5125, correct? Now it's clear. This is 0.725, and here is 0.90125. Good. Once you get these determinants, now you have obtained the determinants, you need to come here and get the cofactor matrix. We need to find the cofactor matrix. How do we get the cofactor matrix? Remember, I had given you that the sign changes in this manner: plus, minus, plus, negative, plus, minus. Then this is plus, minus, plus. So our minor matrix should change with this. So it therefore means the first one being 0.865 will remain the same, because that is 8685 remain the same. Then the second one I introduce negative, but from the determinant there of the minor matrix, it is already negative. So what do we do? Negatives times negative give me positive. So this will give me, now this becomes positive. That is 0.03075. The other one remained positive, 0.01. We are done with that one. We move to the second column. We are having, this will be negative, negative, then give me 0.0565. Then positive, positive, this is 0.8785. The sign does not change. But the other one, because it's negative, the sign will change. That is 0.0195. Remember the signs, when you have negative followed by a negative, the sign becomes a positive. Or negative times a negative, the sign becomes a positive. Finally, here I'm going to have 0.5125. This is 0.725 and 0.90125. This one, we call this one cofactor matrix. This one is called cofactor matrix. Now we need now to find the inverse. How do we find the inverse? The inverse is 1 over the determinant. 1 over the determinant multiplied by, you need to find the determinant of this matrix. We find the determinant of, because we need the inverse. If you want to find the inverse, is 1 over the determinant. How do we find the determinant here? The determinant here, if I want to find the determinant, already have my cofactor here. My cofactor for first column, first row, 0.8685. I multiply by, go to the matrix. What did we have here? Here we had 0.95. So I'll come here and multiply this one by 0.95. Plus, the next cofactor here is 0.0565. I go back to my matrix. Here I had negative 0. Here, negative 0.025. I come here, multiply this one by negative 0.025 plus 0.5125. I multiply by what? I multiply by this one, negative 0.01. Multiply this one by negative 0.01. So this, when you add this one, you get the determinant, which is 0.818575. You take 0.8685 times 0.95 plus 0.0565 times negative 0.025 plus 0.5125 times negative 0.01. Now this will give you the determinant. We need to find the inverse. The inverse is 1 over the determinant, 8185375. Then you transpose. You know how to transpose the cofactor matrix. What was in the row becomes the column, and what was in the columns becomes the row. So here I want to transpose the cofactor matrix. 0.8685, 0.0565, 0.5125. I'm transposing the cofactor matrix. This is 0.03075, 0.0. This is 0. What? 0.8785. Then we have 0.725. The last row, this is 0.01, 0.0195, and then this is 0.9. 0.90125. This is what we called the inverse of a 3 by 3 matrix. So we multiply this one with our demand. The demand you have been told from the question is 500, 1,600, then 2,000. At this point, how do we get, for instance, I want to get demand for X1. If I want to get X1, the value for X1 should be 1 over the determinant, 0.8185375 into bracket, the first row times the column. This means 0.8685 times 500 plus 0.03075 times 1,600 plus 0.01 times this is supposed to be 200. If you go to the question up here, you are told that the demand is 500, 1,600, this is 2,000. It's supposed to be 2,000. The demand here, this is 2,000. This is 2,000. So we use our calculator to find X1. 0.8685 times 500 plus 0.03075 times 1,600 plus 0.01 times 2,000. This will give me X1. Then it is 503.45. You divide by the determinant, 0.08185,375. So give me 615. X1 is 615.06. We do the same for X2. X2, you do the same. 1 over 0.8185375 into brackets. We multiply 0.0565 times 500 plus 0.87585 times 1,600 plus 0.0195 times 1,600. If you do this, you find X2. You find X2 giving you 1,000. X2 giving you 1,799.37. And finally, we go to X3. X3, 1 over the determinant, 0.8185375 into 0.5125 times 500 plus 0.725 times 1,600 plus 0.90125 times 2,000. This one give you X3 to be 3,932.32. Now, what do this X1, X2, and X3 represent? You are told, using the information given below, determine the level of output necessary. That means the X1 should produce 615 units. Because of this 0.06, of course, you can't produce half a unit. This one will give you 616. So, in summary, if you are to give your answer, you can't produce 0.06 unit. It means that they need to produce X1 will be 616. Then X2 will produce 1,799. This gives, round off this one, this gives 1,800. This gives 1,800. And finally, X3 will give you 3,933. You might say it's a lengthy question, but it is worth the marks. Remember, this question is you are working for 12 marks. Yeah, 12 marks. Then you need to show you are working in order. Otherwise, thanks for watching this. We look forward to meet in the next video.